So hello and welcome in this video on movements. So in today's video we are going to discuss about the movements and their uses. So in statistical data many times we are interested about certain characteristics of the data, means we are looking for the measure of central tendency, or you can say the mean, or you can say the measure of dispersion, means variance, or the standard deviation. And similarly we are also looking for two more characteristics, which are skewness and kurtosis. Okay, so we are looking for these many characteristics of the data, and we can determine all these characteristics once we have the movements with us. So first of all, let us discuss what do we mean by movements. So movements are generally defined as the average of various powers, average of various powers of deviations, powers of deviations taken from mean or any other number, okay, or any other number. So in general, from this definition we can infer that in order to calculate the moments we have to find out the deviations. Okay, it is very important that we are looking for deviation from either the mean or some number. Okay, so if we represent the exact mean, okay, mean by x bar, and any other number, so we are fixing one number which is 0 and some other number a. Okay, so this is neither mean nor 0, or you can say that it is an arbitrary number. Okay, so this is an arbitrary number, you can say this is an arbitrary number. So now you have to find out the deviations, and you can find out the these deviations from mean or from any other number, means either from 0 or arbitrary number a. Now how do we decide that what type of deviations which we need for a particular case? So in general, let us first classify the moments. So when you are calculating the moments about this exact mean, so we call these moments as central moments. And when we are calculating the moments about the number a, so we call these moments as arbitrary moments. Okay, so this is arbitrary moments. And when you are calculating the moments about 0, so this is known as the raw moments. Okay, so in general we have, or you can combinedly you can call these moments as non-central moments. Okay, because these moments are not about the exact mean, right? So these are our non-central. So in general we are having two types of moments. First is central and the second one is non-central. And we classified these non-central moments again into two categories. The first one is raw moments and the second one is arbitrary moments. So raw moments are the moments when you are calculating the deviations from 0, and arbitrary moments are the moments when you are taking the deviations from the arbitrary number. So now, in order to get a clear understanding, we can write the formula, but before that we have just some notation. So sometimes the moments are represented by mu or omega. Okay, so central moments are represented by mu or omega, while the non-central moments, so we are just putting this prime over this mu or omega. Okay, so we are having this mu dash or omega dash. So whenever we are having some dash or prime is written over this mu or omega, so these are our this signifies that we are dealing with non-central moments, and when there is no prime involved in the notation, so we are dealing with the central moments. So now just write the formula. So our formula of the moment, so if you are calculating the RF moment, so the formula is summation dr over n, and this is for the data when you are not having any frequency involved, right? Or you can say that if you are dealing with an individual series, means a data where no frequency is given, means no discrete or continuous data we are having. Now if you are having some continuous data or some discrete data, so you have to multiply each power of d by the corresponding frequency and divide this by summation f. So this is when you are having some discrete data, okay, or you can say that you are having some continuous data, right? So if you are having some continuous data, then you can use either, in the case of discrete or continuous data, you can use this summation fdr over summation f. So now you can see that in general we need 4 moments. So you can write the formula of 4 moments separately. So this will be mu1 is equals to summation d over n, means this is the case when you are having individual series. Similarly, you are having mu2 as summation d square over n, where this n represents the number of observations, right? And this mu3 is summation d cube over n, and this mu4 is summation d to the power 4 over n. So this is how we can have the formula for, you can say, the individual series, means when you don't have any frequency in the given data. Now similarly we have the formula for the second case, means in the case of this discrete or continuous data. So our formula will be, for mu1 we are having summation fd over summation f, mu2 will be summation fd square over summation f, mu3 is summation fd cube over summation f, and mu4 will be summation fd4 over summation f. Okay, so this is the case when you are having this discrete, okay, this discrete or continuous data. Okay, so the important thing, as we discussed in the beginning, is this deviation. Okay, so the calculation of the moments, or the, you can say, the categorization of the moments is totally depends on this d. Okay, so if you are calculating this d from the exact mean, okay, if you can calculate this d from exact mean, which we generally represent by mu, means what you are doing, you are calculating this as x minus mu. This is your d, and this x will be the observations given in the data. Now you can also calculate this d from 0. So in this case your d will be x minus 0, okay, which is x and which is equals to d. So in this case our observations itself will become d. And the third possibility is you are calculating this d from some number a, which is your arbitrary number, okay. So you are calculating the deviation from any arbitrary number, means you are calculating this as x minus a, which is d. Now the important thing is here this a is neither 0 and this a is not equals to mu. So now we have an understanding that we are having two types of movements in general, which are our central and non-central movements. Now the important thing is we get all information, okay, all information means the characteristics which we discussed in the beginning of this video. So all information are provided by the central moments, okay, by the central moments. Except mean, okay. So we get all the information. All the information means you can say that we can have the information on variance or the measure of dispersion, and once we are having variance we can also talk about standard deviation. We can talk about skewness as well as kurtosis, okay. So we have all these three information from the central movements. We discussed later in this video how do we get these informations, and however the central movements will not provide any information about the mean of the data, okay. So mean is provided by the first moment about origin, or you can say the number 0, okay. So we can get the first moment about 0, and this will provide us the mean mu, right. Now when you have to find out the variance, you need the second central movement. So second central movement will provide us the information on variance, while skewness will be provided by the second movement and the third movement. And at last, if you talk about kurtosis, so this is provided by mu2 and mu4. So we get this information from the central movements. From this we have another remark that no information will be provided by arbitrary movements, okay. So if you are having arbitrary movements, then these movements will not provide any information. Means you don't you cannot find mean, you cannot find variance, skewness as well as kurtosis if you are having the values of the some arbitrary movements. Then what is the need of the calculation of these arbitrary movements? So later we will discuss about this. So now it is very clear that if we have the movements, if we have the first movement, if we have the second movement, so this will provide us variance. If we have to calculate or we have to look for the type of skewness, then we need the second and third movement, and all these movements are central movements here. And in order to calculate the kurtosis, we need mu2 and mu4. Now, if you talk about central movement, so first central movement is always 0. So this is your first central movement. Okay, so this is your first central movement. So first central movement is always 0 because the sum of the deviation taken from the exact mean is 0. So that is why first central movement is always 0. However, from the expression we know that mu2 can be obtained or is involved the second power of d, okay, or you have this as summation fd square over summation f. So this cannot be negative. Why? Because you can see that this involved the second degree of the deviations. So this will always be positive, and n is the number of observations and similarly f is the frequency. So this is not negative. So all the quantities involved here are positive. So second moment is always positive, which is necessary because this gives us variance, and we know that variance cannot be negative for any data. So this will always be positive. Now mu3 is if you are looking for mu3, so the formula of mu3 is summation d cube over n, or you can say summation f d cube over summation f. So here again the sign of the moments totally depends on the deviation, because number of observation cannot be negative, similarly frequency cannot be negative. So this third moment involved the cubic power of the deviation. So this can be negative or 0 or positive. So your third moment can be negative, 0 or positive, while mu4 is simply defined as summation d4 over n, or you can say summation f d4 over summation f. So this is always positive, or you can say that cannot be negative, or you can directly write it as always positive. Okay, so this fourth moment is always positive. Now let us discuss some problem on the movements so that we can have a clear understanding. So let us discuss about our problem number 1. So here we are given marks for 5 students. Okay, so we are given the roll numbers of the student as well as the marks. So we are having 5 students as 1, 2, 3, 4, 5. These are the roll numbers, and marks are given as 15, 10, 20, 18, 17. So you can see that in this data no frequency involved. Okay, no frequency. Don't get confused with this. This is not the frequency, this is simply the roll number. Frequency is the repetition of any observation. So this is not repetition, basically this is given as the roll numbers. So the student whose roll number is 1 get 15. Similarly, a single student whose roll number is 2 obtain 10, and roll number 3 gets 20, and so on. So this is simply the roll number. This is not the frequency. So we are having individual series, and we have to find out the central moments. Okay, in this case, central moments. So we have to find out the central moments. So we know that if we have to calculate the central moments, then central moments are calculated. So let us begin with the solution. So central moments are generally calculated about exact mean, mu. Okay, means we have to take the deviation from the exact mean. So here we have to first find out the our exact mean here. So mu can be obtained by simply adding all the observations and divided by the number of observations. So the sum of observations means we have to add this 15 plus 10 plus 20 plus 18 plus 17, and we have to divide this by number of observations. So we have 5 observations, so this is simply coming out 80 over 5, and this gives us the mean as 16. So now we calculate this deviation. Now we have this formula, so you can write this as x minus 16. So let us make a table here. We are having x. Okay, so the values of x are 15, 10, 20, and we have 18 and 17. Now we calculate d, which is x minus mu, or you can write it this as 16. Okay, so 15 minus 16 is simply minus 1. 10 minus 16 is minus 6. This is 4, this is 2, and this is 1. Now we know that we have to find out 4 moments. So we have to complete this table up to d to the power 4. So next we find out d square. So d square means the square of these values here. So when you square minus 1, so this will give plus 1. The square of minus 6 is 36. The square of 4 is 16. This is 4, and here we are having 1. Similarly, we will find out d cube here. So d cube is again the power of this d square. We have to multiply this d square by d. So this is coming out d cube. So 1 into minus 1 is minus 1. This is minus 216. Next we are having 64, then 8. Lastly we have 1. Next we can have this d to the power 4. So this is 1. And here we are having 1296. And next we are having 256. And we are having 16 and 1. So now we know that this is our summation d is always 0. Why? Because we are taking this deviation from the exact mean. Okay, and the sum of the deviation taken from exact mean is always 0. Now we have next we have summation d square. So our summation d square is coming out 58. Similarly, summation d cube is coming out as minus 144, and lastly we have summation d to the power 4, and this is 1 5 7 0, and so our first moment, because we are calculating the central moment, so this is always 0. Now we have mu2, so mu2 is summation d square over n, so this is 58 over 5, so this is coming out as 11.6, and similarly mu3 is summation d cube over n, so this is minus 144 over 5, and this is coming out as minus 28.8, and lastly we have mu4, which is 1, or you can first write the formula, so this is summation d4 over n, so this is 1 5 7 0 over 5, so it is coming out as 314. So this is how we can obtain our central moments, and the important thing is, as we see in the beginning of this video, that the type of the moments is determined by this deviation. If you are calculating this deviation from the mean, then it is central moments, and if you are calculating the deviation from any other number, then we call such moments as non-central moments. However, the main informations will be provided by our central moments, so we always calculate, or we always looking for the central moments, but yes, sometimes we calculate non-central moments. And what is the advantage? So before that, let us take one more problem, so on the discrete data. Okay, so we are having another problem here, and in this problem we are given a discrete data, so we are having in observations and together with the frequency. So our observations are 2 4 6 8 10, and we are having the corresponding frequencies as 4 2 3 2 and 1, and again we have to calculate the central moments here. Okay, we have to calculate the central moment. So sometimes it is given in the question that you have to calculate the central moment, or you have to calculate the moments about some number. So if it is given in the question, then we directly opt for that those moments. Otherwise we have our own choice, but again after this example we will discuss the use of non-central moments, and if the information is provided by the central moment, then what is the role of the non-central moment. So first we will discuss this problem here. So again we know that in order to calculate the central moments, first of all we have to calculate this mu. What is this mu? This is your mean. Okay, and we know that in the case of discrete data, we know that mu will be calculated as summation fx divided by summation f. Okay, so summation fx means the product of observation with the corresponding frequency. So we can insert one column here which contains the product of the observation with the respective frequency. So here when you multiply these the first observation 2 with the corresponding frequency 4, so you will get 8, again you will get 8, here you will get 18, here it is 16, and lastly we are having 10 and 1. So when you multiply these quantities, so it is coming out 10. So this gave us the sum of xf, and this is coming out 60. Okay, and this second column will give us the value of summation f, which is 12. So we put these two values here, which is 60 and 12, and you will get the mean as 5. Okay, now once we are having the mean, now we can calculate the movements by calculating the deviations. So let us make the table similar to the previous problem. So we are given the observations, we are given the frequencies. So observations are 2, 4, 6, and we are having the next observations are 8 and 10. So observations are 8 and 10, and the frequencies are 4, 2, 3, 2 and 1. So now first of all we will calculate the deviation, which is x minus mu, or you can say x minus 5. So x means the observations. So observations are given in the first column. So when you subtract 5 from the first observation, which is 2, so you will get minus 3. So this is minus 1 because the next observation is 4. This is plus 1, 3 and 5. Now we next multiply this frequency with the deviation. So this frequency, first frequency is 4 and the corresponding deviation is minus 3. So this is minus 12. This is minus 2. This is 3, 6 and 5. Now next we will find out FD square. So we multiply this FD by the corresponding deviations. So you will get 36, 2, 3, 18, 25. Then we have FD cube, which is coming out. FD cube means you are multiplying FD square with D. So this is minus 108 because 36 multiplied by D, which is minus 3. Similarly 2 multiplied by minus 1 is minus 2. Next we have 3. Then 54. And lastly we have 125. Next we have FD4. Why? Because we have to calculate the first 4 movements. So we need this d to the power 4. So this can be obtained by multiplying the entries in this FD cube column by the corresponding deviation. So FD4 will be coming out as 324. Then we have 2, 3, 162, and lastly we have 625. So from this table you will get summation FD. Summation FD means the sum of this column. So summation FD is coming out as 0, which is certain. Why? Because you are calculating the deviation from the exact mean. And next we will have summation FD square, and summation FD square is coming out as 84. Next we have summation FD cube, and this summation FD cube is coming out as 72. And lastly we have summation FD4, and this summation FD4 is coming out as 1116. So our mu1 is 0 because this summation FD is 0, and we discuss in the remarks that our first center movement is always 0. Center movement means when you are calculating the deviation from the exact mean. So we can have this mu1 as 0 and mu2 as summation FD square over summation F. So this is 84 divided by 12, and when you divide this 84 by 12, so it is coming out as simply 7. And similarly mu3 will be summation FD cube divided by summation F. So this is 72 divided by 12, so again it is coming out as 6. And we have mu4 as summation f d4 over summation f, and from this you will obtain the fourth moment as 1116 divided by 12, and this is coming out as 93. So this is how we can obtain our central moments. Now why we need the non-central moments? So the sole reason is sometimes, so here we have a remark, so sometimes mean is obtained in decimals. Okay, it is possible that you may have your mean in terms of decimals. So what is the problem with this? Because if you are taking the deviation from some quantity which is involved in which is given in terms of decimal, so your deviation is also coming out in decimals, and that makes this process complicated, right? So this is a complex calculation. Okay, so to avoid this, what we will do, we will obtain, so we in this case we obtain the non-central moments. Okay, so we'll calculate our non-central moments. Now what is the use of this? Because as we discussed in the beginning that we get all the information from the central moments only except the mean. So if we are having non-central moments, then what is the use of those moments? So here we are having certain conversion formulas. Okay, so we have conversion formulas. So conversion means we can convert non-central moments into the central moments. Okay, so we have conversion formulas. So as we know that mu1 is always 0, and because I am not using any dash or prime here, so it is very clear that it is our central moment. Now mu2 can be obtained using the non-central moments mu1 dash and mu2 dash by using this formula. So it is simply defined as mu2 dash minus mu1 dash square. Similarly, mu3 can be obtained as mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. And next we have mu4, and mu4 will be mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash to the power 4. So we use these formulas and we can convert our non-central moments, which are easier to calculate, into the central moments, right? So let us discuss here a problem. Okay, so we are given a data. So here we are having a problem. So we are given a data, or you can say here we are having the continuous data, means class interval along with their frequencies. So our first class is 2 to 4, next is 4 to 6, next we are having 6 to 8, next we have 8 to 10, then lastly we are having 10 to 12, and we are given the frequency also, which is 4, 2, 7, 6 and 1, and we have to again calculate the center moments. So what we will do, we because in order to calculate the moments we need the observations here, but we are provided the class intervals, so we obtain the observations by taking the mid value of each class interval. So it can be coming out as 3, 5, 7, 9 and 11. Now in this problem we will calculate the non-center moments first, and after that we will convert those non-center moments into the central moments using these formulas. So here we will consider the arbitrary number as this observation 7. Okay, why we are considering this? Because 7 lies in the middle of these values, because x starts from 3 and ends at 11. However, it is not necessary that you always pick the arbitrary number from the data itself. You can use any number, but it will be useful, because once you are picking any observation from the data itself, then the deviation corresponding to this observation will be 0. So let us calculate the moments about 7, and as we discussed that moments involve the deviation. So here we are calculating the moments about 7, so we are taking the deviations about 7, means we subtract 7 from each observation. So 3 minus 7 is coming out minus 4, so this is minus 2, 0, 2 and 4. Now next we are having FD. So our FD is means we have to multiply this frequency by the corresponding deviation. So this is coming out as minus 16. Similarly, this is minus 4. Here we are having 0. This is 12 and we are having 4. So we are multiplying each frequency by the corresponding deviation, right? So we are taking the product like this. Okay. So when you are taking the product like this, you will obtain the values of FD. Now next we will obtain FD square. So what we will do, we multiply this D with this FD, okay, like this. So this gives us the value of FD square. Okay, so this is 64, this is 8, this is 0, 24 and 16. These are the values of our FD square. Next we have FD cube. Okay, FD cube can be obtained by multiplying FD square by this D, okay, for each values of FD square, right? So this FD cube is coming out as minus 256, minus 16, 0, 48 and 64. Similarly, we have FD4. Now again, if you multiply this D by FD cube, so you will obtain your FD4. So FD4 is coming out as 1024. This is 32 and we are having 0, 96 and lastly we are having 256. Now from this table it is easy to obtain the value of summation f. So summation f is coming out as 20. Now next we are having summation fd. Now because this is not 0 in this case, why? Because we are calculating the deviations from any arbitrary number which may or may not be equals to the exact mean. So that is why this summation FD is non-zero, and this is coming out as minus 4. Next we are having summation FD square. So summation FD square is coming out as 112, and next we are having summation FD cube. So this is coming out as minus 160, and lastly we are having summation FD4, and summation FD4 is 1408, right? So we can obtain our first moment, and because we are calculating the non-central moment, so it is a good practice that you put the prime over this symbol mu. So mu1 dash is summation FD over summation F, and summation FD is minus 4 and summation F is 20. So this is minus 4 upon 20, or you can say minus 0.2. Similarly, mu2 is equals to summation FD square over summation F, and summation FD square is 112 divided by the summation F, so it is 20, and this is coming out as 5.6. Next we can find out mu3 dash, and mu3 dash is defined as summation FD cube over summation F, and summation FD cube is minus 160 over 20, so it is coming out simply minus 8. And lastly we will obtain our fourth or last moment, so which is defined as summation FD4 over summation F, and summation FD4 is 1408 divided by 20, and this is coming out as 70.4. Now we have all four moments with us, but the problem is that these moments will not provide any information, because these moments are calculated about an arbitrary number, and this number is not mean is certain, because if it is mean, then this first moment should be 0, or you can say that summation FD should be 0. Whenever we are having this summation FD non-zero, it means that we are dealing with non-central moments. So now we have the conversion. Okay, so conversion means we are converting these non-central moments into central moments. So our formula is mu2 is equals to mu2 dash minus mu1 dash square. So we put the values here. So mu2 dash is we calculated as 5.6, so this is 5.6 minus mu1 dash square, so it is negative 0.2, and when you put this square, so it will become a smaller quantity, and this is coming out 5.56. okay, and similarly mu3 will be, the formula is, it is mu3 dash minus 3 mu1 dash mu2 dash plus twice mu1 dash cube. So when you put all these formulas here, so this is minus 8 minus 3 into mu1 dash, and mu1 dash is minus 0.2, and mu2 dash is 5.6 plus 2 mu1 dash cube, so mu1 dash is minus 0.2, and we are putting cube over here. So this will be obtained as, our third moment is coming out as minus 4.65. Lastly we have mu4, and again we are using the same formulas, or you can say the same conversion formulas, which is mu4 is mu4 dash minus 4 mu1 dash mu3 dash plus 6 mu1 dash square mu2 dash minus 3 mu1 dash to the power 4, and we know that we have all the values with us. So when you put this mu4, the value of this mu4 dash, which is 70.6 minus 4 multiplied by minus 8 multiplied by minus 0.2 plus 6 multiplied by 5.6, which is the value of mu2 dash, and the value of mu1 dash is 0.2 negative. So this is minus 0.2 whole square minus 3 times mu1 dash to the power 4, so which is minus 0.2 to the power 4. So when you simplify or calculate all these values, so this is coming out as 65.3392. Okay, so this is our force center moments, and this is the procedure to convert our non-central moments into central moments. And why we are needing this conversion? Because we get all the information from the central moments. Arbitrary moments will not provide any information, right? So this is how we can calculate our moments. In fact, we calculated all central moments except this last problem. So we convert these non-central moments into the central ones, right? So this is how moments work. Now another important thing is, if you have to find the variance for any data, so in that case you need mu2. Okay, and mu2 means the central moment, second central moment, right? And another important thing is, in the conversion formula, okay, in the conversion formula, mu r's means the moments, so we are having this as a remark. So in the conversion formula of mu r's, all non-central moment should be calculated about the same number. Okay, so why we are having this remark means, if you are given the first non-central moment as 2, and this is about origin, or you can say 0, and you are also provided mu2 dash as let's say 6, and this moment is about let's say 5. Now you cannot use mu2 is equals to mu2 dash minus mu1 dash square. You cannot use this formula. Why? Because the first non-central moment is given about 0, while the second non-central moment is given about 5. So we cannot use this type of moments where one moment is given about some number and the other moment is given about some another number. So we cannot use the conversion formula in this case. Okay, so this is how we can calculate the moments. We can how we can calculate our non-central moments into central moments. Okay, so we will discuss more about in our next video.